let me introduce myself first. My name is Andrey Slastenov. I'm head of security at Gcore, working on security solutions for more than 5 years and have a strong over 20 years background in telecommunication. Gcore is one of the biggest European-based AI, cloud, CDN, and security providers with headquarters in Luxembourg. And today the topic of our discussion will be modern DDoS threats and multi-layered mitigation tactics that we use for our customers within Gcore network. We also deep dive into how layered protection enhances the overall cybersecurity strategy. But first of all, let's start with a short warm-up and look at the security landscape that we have at the moment. I will divide this landscape into 3 categories. The first includes threats that primarily target systems and infrastructure, aiming to overload them or exploit vulnerabilities through different attack vectors. The second category covers malware and access control. And the last category is, I would say, kind of human element, like social engineering. All of these threats to different degrees define what we may face as security challenges within our company. Some of these categories can usually be addressed internally. For example, malware and unauthorized access can be mitigated through authorization policies or antivirus software. Social engineering can be mitigated with training, awareness programs, and clearance procedures. But when it comes to system overloads or large-scale exploitation attacks, issues cannot be easily solved with resources of the single security department. And let me just explain why. If we look at the numbers, so we collect the data for over 3 years. And we focusing on the attacks that mitigated in 2025, we can see that in the first half of the year, the largest attack on one of our customers reached more than 3 terabit per second. And that's about 2 endpoints more than we have in previous year. Looking more closely, the maximum attack values peaked 1.7 billion packets per second. Just to put it into the perspective, and give the real world example, if each packet has size of 1,500 bytes, which is common MTU in the network, the potential magnitude of that attack would exceed 20 terabit per second. With default packet size distribution on the internet, it is 4.6 terabit per second. So the 3 terabit per second and more or less close to the real values, real numbers on the internet. And this is clear that for medium-sized or even large enterprise, any data centers can just have this level of capacity or processing power to withstand and mitigate such attacks on their own. That's why organizations usually need external support to protect their IT infrastructure. Just if you look at a few other numbers from our daily observation from 2025, on average, we mitigate around 500 attacks per day across different attack vectors. Over the past few years, the average duration of DDoS attack has decreased significantly. Short spike lasting only something about 30 seconds, which make detection of that attacks even more difficult. Just to sum up, the multi-terabit and billion packets per second DDoS attacks is not longer rare. They have become part of everyday threat landscape. These attacks don't always appear as a single short spike, but often come in waves. So as you can see, and this data is just getting from our internal monitoring system, there are multiple spikes within certain time period, which makes detection of every single spike very challenging. In addition, this constant pressure exhausts the targeted system. Most of their attacks today usually, in most of the cases, delivered in the series. If one attempt is successful, it's often repeated within hours for weeks long. In some cases, this continues until significant harm is done, or until the attacker gets some ransom from the company. What the problems businesses usually face with DDoS attacks and online threats? First of all, there is financial losses, both direct and indirect. For example, if you run a retail business with like an online shop, every minute your website is unavailable means loss of potential revenue. Second, there is reputational damage. If DDoS attack successfully disrupt your service and the information becomes public, customers may lose the trust in your company. The third, there can be legal consequences. For instance, if DDoS attack is combined with attempt to breach security system and steal some customers' personal data. Fourth, there's operational disruption, and it's always happened. Such attack place your internal staff under stress for them to work in crisis mode, and usually always generate additional internal expenses for mitigation. And finally, as the result, there is a customer impact. So if customers cannot buy from your website or use your service, then they will simply turn on to the competitors. So they can just find the company who can provide them that service. When we talk about DDoS attacks themselves, it usually falls into two main categories: Layer 3 and Layer 4 attacks and Layer 7 attacks. Layer 3 and Layer 4 attacks are the simplest and in many cases the most brutal. So the attacker floods the infrastructure with massive volumes of the traffic, sometimes reaching terabits per second. The traffic is not necessarily aimed at specific application, but simply overwhelms the infrastructure just to disturb the availability of your resources. These attacks require a lot of resources on the attacker side, so they rely on large botnets to generate a big amount of the traffic. And another story is the Layer 7 attack. They are more precise. Instead of overwhelming the entire infrastructure, they focus on specific applications, such as, for example, your website, like DNS server or VPN server, or any real-time services like it can be the gaming or streaming, whatever. The goal is to overload that particular service with the request until it becomes unavailable. So these attacks typically cause very high CPU utilization and service or memory utilization and service outage for the exact attacked resource. So if we talk about which services are most vulnerable to the DDoS attacks, in general, there are all applications that's exposed to the internet. For the attack to be delivered, attacker needs access to your infrastructure, which means that if your resource have a public IP access or accessible website, it can be attacked. The first and most common target is websites and web application. In today's world, almost every company has some online presence, so it can be like complex web portal or even small landing page that makes that resources prime target for the attackers. The second is network infrastructure. Even if a website is protected by security provider, the underlying network infrastructure is still exposed and can be attacked directly, often with I would say, the same effect as attacking the website itself. And finally, it's now very popular and growing target API and online services. As more application and businesses rely on the API and online presence, for example, for mobile apps, online banking, or other integrations, there is endpoints becomes attractive to attackers. In short, if you have a routable IP address on the internet, it can be potentially attacked by malicious actors using various kind of techniques. So I mentioned this briefly on the previous slides, but DDoS attacks can generally be divided into two major categories. The first is infrastructure attacks, which is mostly volumetric. These attacks include amplification attack. In this case, the attacker takes advantage of misconfiguring public services to just reflect and multiply the traffic, creating massive floods of the packets. Another common method is connection-based flooding, such as TCP SYN flood. For example, in SYN flood, the attacker sends millions of half-open TCP connections that consume server resources until it can no longer respond and just disturb your service. The second big category is application attacks at layer 7. They are more precise and harder to detect. Examples include like HTTP GET POST floods that simulate real user just working with website, just normal behavior. Beyond the websites and API, attackers frequently goes after DNS resolvers, DHCP servers, VPN servers, and any other real-time platforms. So application layer attacks often mimic the normal user traffic, which make them very difficult to detect and mitigate. Defending against them requires, I would say, deep packet inspection and advanced countermeasures. Just to give you some examples, the first and most dangerous scenario is when the attacker tries to fully imitate a legitimate user. Instead of just sending random malicious traffic, the botnet generates traffic that looks almost identical to the customer browsing your website or using your application. This forces security system to analyze the actual packet content. Just look inside the packet and analyze it very deeply to detect patterns and decide if that traffic belongs to legitimate workload. So DPI is the critical here as the part of the DDoS protection. It's allow inspection of the packet payloads, helping to separate fake traffic from the valid user request. In some cases, even DDoS protection can mimic real application traffic to challenge potential potential source IP addresses participating in the attack. For web application specifically, there is a dedicated set of tools such as web application firewall and IP protection, like API protection, like WAAP. So that tool can analyze HTTP request in details and block the malicious payload. So that makes such attacks very dangerous because they blend into normal traffic flow and very difficult to stop without advanced protection. So the successful mitigation requires a combination of different technologies, DPI, WAAP, behavioral analysis, and even kind of AI-driven detection models. So what do we use to fight that different types of the attack, layer 3, layer 4, and layer 7? The first line of defense is access control, not just a basic kind, but intelligent adaptive controls. That include whitelist, blacklist, reputational-based IP list that help us to decide in the real time whatever is source is truth, whatever this source can be trusted. We also use the standard access control list, and in some cases, additional authorization mechanisms that check packet flows and verify that source of IP belongs to the real customer, and before allowing the further communication. One of the simplest countermeasure that works in that way, it's like a TCP cookie challenge. Next, we use wide range of ref limiting techniques. It's not just a simple, one size fits all limiter. We have a source-based rate limiter. We can granular and flow-based limits to regulate specific traffic streams, TCP session limits to stop excessive connection attempts, protocol-based limits to focus on UDP or CMP or TCP individually, or even geo-based limits that can restrict some traffic based on the certain regions. We also deploy the signature analysis to identify no malicious patterns and packet validation to ensure that each packet actually complies with protocols it's claimed to represent. And of course, for advanced attacks, we use deep packet inspection and machine learning models that automatically learn traffic attack signatures during ongoing attack and block traffic accordingly. So this layered defense ensures that no matter if it's volumetric or connection based attack, or even its target application layer, we have all tools that can help us to mitigate that kind of attacks. If we just talk about the WAP, it is really a whole different world because it involves a wide range of the tools working together. So a web application firewall, it's but primarily protects against GNU vulnerabilities and exploitation attempts, such as, for example, SQL injection. The WAF inspect HTTP requests in detail, applying the rules to block malicious payloads before they even reach the target application. Also, we have a bot protection. This is the critical against scraping, credential stuffing, fake form submissions, and other type of automated abuse. For bot protection, we use also different techniques: capture, behavioral analysis, JavaScript challenges, just to distinguish the real users from the bot. We also can apply HTTP flood mitigation, which is part of our DDoS defense stack. This ensures that malformed requests drop before they consume all the resources of web application. So finally, it's important to understand that effective protection requires two complementary layers working hand to hand. The first layer is DDoS protection at the network and transport layers. This just defends from the volumetric attacks and other protocol-based attacks that can overwhelm the infrastructure. The second layer is web protection at application layer, powered by web application firewall that inspects HTTP requests in details and just stop application layer DDoS attacks. As I mentioned earlier, the attacker usually adapts their tactics. So if they cannot bring down your application directly, so if you're well protected by web application firewall or WAP, like web application API protection, they often target your infrastructure. So instead of overloading your web application, they're trying to overload your servers and network capacity until the application becomes unavailable. So that's why both protection must work together as the part of multi-layered security strategy. Just to give you the real example, if a web security provider filter out malicious HTTP request and hide your application IP address, like web application IP address, the underlying infrastructure is still exposed. Anyway, at some point, legitimate traffic must be delivered to the servers from your web security provider. And without strong network layer DDoS protection in place, attacker can still overwhelm just your infrastructure and the path that carries this traffic. So here is the just example of the architecture that we use in Gcore to protect our customers. So all of our security protection is the part of our CDN infrastructure, which means that we have scalable protection available at every layer. Our platform is built on large Anycast network with thousands of global distributed CDN nodes. So this design allows traffic to be load balanced automatically across multiple locations. So when attack happens, the malicious traffic is spread out and absorbed by entire network instead of just hit one specific data center. This strategy allows us to withstand even multi-terabit scale DDoS attack. At Gcore, as I mentioned, our DDoS protection deeply integrates with CDN service, but also we provide DDoS protection services for all our services that exist in our company: CDN, hosting, and cloud. We can provide protection not only to customers already using their services, but also to the customers outside of our network, thanks to our extensive peering relationship and support for GRE tunneling. We able to handle traffic very efficiently because way how the infrastructure is built. And another interesting point that because we are CDN hosting cloud provider, we mostly focus it on outgoing traffic delivery. So it means that we are like a big storage of the resources. And at the same time, it means that our incoming capacity, and usually the DDoS protection is always traffic coming in, is underutilized, which gives us like very unique opportunity to reuse it for DDoS protection. So that means we can absorb and mitigate very large attacks volumes while continue to provide customers service without any kind of the disruption from our side. So here is just some numbers about our network. So if you look at our network as the whole, our total filtering capacity exceeds 200 terabit per second. So we get this number by multiply the performance of each node on the total amount of the nodes that we have. So that gives us scale to handle even the largest global attacks that now we see on the network. So we operate more than 118 points of presence worldwide, which allow us to deliver service with minimal latency. So we not only clean the traffic, we also reduce the latency because the traffic is clean as close to the source as possible and no need to travel to any specific cleaning center. And that's why we mitigate DDoS attacks at very beginning. We have a lot of companies that use our services, DDoS protection services and web security services. They just presented here. As you see, there's different companies, big enterprise, medium size, and even the small one. And I think just to wrap up our session, just to conclude today's session, let me highlight 3 key takeaways. The first, comprehensive protection is the strongest defense. Effective cybersecurity requires not just only one layer of the protection, but combination of the DDoS protection and web application security. The second integrated approach is essential. So by combining multiple security layer into just unified framework like we do in Gcore, you can ensure that your services stays online all the time. And finally, so our Gcore defense is I think the biggest advantage is our ability to bring all services together as one solution: the DDoS protection, web application security, and CDN, like a single powerful integrated solution that delivers good protection and good performance in the same time. So with that, thank you for your attention, and I think we have 5 minutes for the questions, if we have so. Thank you so much.
All right, thank you very much, Mr. Slastenov. We have a few minutes for questions. First one is, why is a cloud-based protection more scalable than traditional on-premises solutions?
Well, the first reason, because the cloud-based protection just use, as I mentioned in my presentation, global distributed infrastructure. So the capacity is very flexible. It can absorb and filter massive attacks close to the source without being limited by customers' own hardware or bandwidth, because usually the enterprise always have a limited scale of the resources. So traditional on-premise appliance can scale only by this amount of the boxes that you can install in your data centers and the capacity of your uplinks. And in the modern world with 3 terabit per second attacks, virtually no one has such amount of the capacity and performance. In the same time, we just reuse our existing equipment. So we already have a CDN network. We just reuse that big network to filter the traffic. So we have enough capacity to clean even the huge attacks. That's why I would say that if you look at the current state of DDoS protection, everything is migrated to the cloud. Before it was like a local appliances, on-premise appliances, but with this magnitude of the attack, it makes no sense to clean the traffic in your data center, because even before it reach your appliance, before it reach your box, the traffic can overwhelm your uplink and you virtually can do nothing with that. So that's my answer on this question.
Okay, and can even small businesses become targets of DDoS attacks? And if so, why?
Yeah, it's a very interesting question, because even, of course, even small businesses can be the target. The large-scale incidents against big enterprises, usually you always see it in the headlines. But it doesn't mean that smaller companies are unaffected. From our experience, any organization with online presence can be vulnerable. The difference why maybe you may think that small companies is not affected to the DDoS attacks, that the small businesses rarely make the news. So you don't see that on the headlines in newspapers and online resources. So, but the impact on them can be even more severe, because the lack of resources maybe not always implement the good DDoS protection. So from experience of our company, we would say that big companies attacks as frequently as the small ones. And yeah, that's also the problem for small companies as well.
Thank you very much for your expertise,
Thank you.
Mr. Slastenov, and have a nice day.
Thank you.